go back and check and make sure that that works out. A woman invested $10,000, part at 9% and the rest at 14%. So there are two things going on here, okay? First off, how much total money is she investing? $10,000. And part of that money is going to earn a 9% interest. And the rest of it is going to earn 14% interest. And we know that the annual interest income from these investments is $1,275. Using that information, we want to figure out how much she invested at each rate. First, let's let X equal the amount that we put in the 9% account. Then that means that 10,000 minus X is the amount at 14%. That's how much we have left to put into the 14%.
So like the X is how much of the 10,000 is going to be?
Right. The X is how much of the 10,000 I've invested in the 9% rate. So we know that 9%, which is 0.09 times X, plus 14% times whatever is left over after I've already used X, so 10,000 minus X. Too many zeros. Those two amounts, those are my interest amounts. This right here is the amount of interest earned from the 9% account, and this is the amount earned from the 14% account. And we know that in 1 year we had how much? 1,275. And then we just solve it. We say 0.09x plus, what is 0.14 times 10,000? 1,400. Minus 0.14x must equal 1,275. Then we just combine like terms and solve for x. 0.09 minus 0.14 is negative 0.05. That's multiplied by x. And then if I subtract 1,400 from both sides, 1,275 minus 1,400 gives me negative 125. And then if someone could calculate for me, let's divide both sides through by negative 0.05. 2,500. So let's talk about what that means. That means that this person, we don't even know her name and we're figuring out her business dealings for her. This person invested $2,500 in the 9% account. We also want to know how much did she invest at the 14%. So how much was it? How much? 7,500. Oh, 7,500. I couldn't figure out what you were saying. At 14%. And I think that works out perfectly. We're going to look at a couple of business applications. And one thing about running a business, if you think about the machinery involved in running it, is that there are a lot of costs involved. One of the costs is called a setup cost, and that includes the cost of installing a machine and preparing it to do a job. Sort of like the copiers in our office down there. It costs us something to have that machine brought in, and we have to pay Xerox to bring it in, or Canon, or whoever it is, to bring it in and set it up for us. That is our setup cost. We pay that cost how many times? One time. That's all. It's just one time. Like, that's the setup cost. We pay it once and we're done. But there's also what's called the unit cost, and that's the cost to manufacture one item on that machine, including cost of material and labor. So for the copy machine, they actually charge us per copy. We rent those, and they charge us for every copy we use. They charge us a certain amount. So part of that is part of the unit cost. But we also have to calculate in the paper. those sorts of things. All of that together is called the unit cost. Whatever it costs to make one item. Knowing those two things will allow us to solve this example. Suppose that one machine has a setup cost of $400 and a unit cost of $1.50, and a second machine has a setup cost of $500 and a unit cost of $1.25. So do you guys understand what's going on there? Basically, one of them costs me more to set up, but it costs me less to manufacture things on that machine. So we're interested in knowing where the break point is. The break point is the number of units manufactured at which the cost on each machine is the same. Somewhere along the way, their cost would be the same, depending on however many, we'll just say copies. It doesn't have to be copies. We could be making shoes or flip-flops or sofas. I don't know. That's legit, though, if it only cost me $1.50 to make a sofa. So let's let X equal the number of units, number of items manufactured, number of sofas, whatever. That's what X is going to stand for. And let's build an expression that will tell us how much it costs to make X units on machine 1. Well, first off, for machine 1, I have to pay an upfront fee of $400 just to get it set up. Plus, it's going to cost me $1.50 times the number of things I make, so times X. That's how much machine 1 is going to cost. Machine 2 is going to cost an upfront cost of $500 plus $1.25 times the number of items I make. And because we're looking for the break point, which is the point or the number of items where it's equal, you just set those two things equal and solve the equation. So if I subtract $1.25x from both sides, that leaves me with 400 plus 0.25x equal $500. Then I can subtract the 400 from both sides. And we have 0.25x equals 100. So if we divide both sides by 0.25, what does that give us? 400. So if we did this properly, manufacturing 400 items should cost me the same on both machines. And you should certainly plug back in and check that. Example